Okay, hi guys. So in this lecture, we'll be seeing what happens for a cyclic process, or rather a non-cyclic process. So for a non-cyclic process, for a non-cyclic process, let's suppose a system goes from A to B. From A to B, it is going irreversibly, and from B to A, let's say this is reversible. But for now, we are only considering what happens in case of a irreversible path from A to B. As we can see that from A to B, we can write it would be dq irreversible by temperature, and from B to A, as it is reversible, so if I add from B to A dq irreversible by temperature, then again the whole system would still be less than 0. Okay, so now we can write that from A to B dq irreversible upon temperature, and this is nothing but from B to A, this is ds, or change in entropy. Okay, so as ds is only defined for dq reversible by T, we are writing it as ds. So from A to B, we see that change in entropy of A to B would be equals to change in entropy of B, entropy of B minus entropy of A. And from B to A, we can write that delta S BA can be written as entropy of B minus, or rather entropy of A minus entropy of B. Okay, so we can see that delta S AB is negative of delta S BA. Okay, so we can write that from this, we can write that limit from A to B dq irreversible by temperature, and if I change the limits, I have to push minus sign ahead, then again the limits would be from A to B, ds would be less than 0. Okay, so from A to B, ds would be greater than dq irreversible by T. Okay, and ds is actually equals to dq reversible by T. So hence overall we can write that ds would be greater than equals to dq by T. It would be holding a equality for reversible process, and it would be greater than for irreversible process. Okay, now let's see the entropy calculation for an isolated system. What happens in case of an isolated system? Suppose we have this system which is partitioned into this vessel, which is partitioned into two blocks, A and B. Okay, and this is insulated. So let me put down a layering of insulation here. Okay, so let's say we have a hot body B which is at temperature TB, and we have a cold body A which is at temperature TA. So change ds of system can be written as dsa plus dsb, and dsa can be written as dq by ta, and ds of b can be written as minus dq by TB. Why we are writing minus sign ahead of dq by TP? Because heat will be flowing from B and going towards A. Okay, so in reversible process, we can write that temperature of B would be equals to temperature of A plus dt, which is at any point of time before the equilibrium, where dt we are taking it as negligible. Okay, and ds of total system would be equals to 0. Okay, because ds of system would be ds of A plus ds of B, and it is insulated, means no heat is exchanged from the surrounding. Hence in reversible process we can write that ds system would be 0. Now let's see what happens in case of irreversible process. So in irreversible process we can write that TB would be equals to TA plus delta T. Okay, and ds of system would be greater than 0. Okay, because these two would be dq irreversible rather. Okay, and ds of the system would be greater than 0. So overall we can say that ds of system would be greater than equals to 0, where we have equality for reversible process and greater than for irreversible process. Okay, so just remember that for the irreversible process, for an isolated system, ds of system would be greater than 0, and for reversible process, ds of system would be equals to 0. Okay, and if ds of system is less than 0, then this is impossible case. Okay, so if you look at the graph of entropy versus time, then we can have something like this. So this is entropy versus time. We'll be having something like this. So this condition is at equilibrium, where delta S of system would be equals to 0, or simply S of system is constant. Okay, so this is the condition when spontaneous process takes place. In an isolated system, entropy of the system increases and reaches maximum value at equilibrium. Okay, so with this we come to the end of this lecture. In the next lecture we'll be seeing more on Clausius inequalities. So till then, good luck and goodbye.